For number 8, if two pulleys with radii 15 inches and 6 inches have centers 18 inches from each other, what is the belt length needed for the pulley system? So the first thing I'm going to do is look at this as a common tangent problem. So I'm going to draw from my radius to the common tangent perpendicular lines. So now we have two right angles there. I'm going to connect the centers, and from there I'm going to draw a line that's parallel to the common tangent to make a rectangle and a right triangle. We are told that the radii are 6 inches and then this whole one is 15. Therefore, if this is a rectangle, we have 6 and 6, and then 6 plus what gives you 15, and that's 9. As always with these problems, they're not drawn to proportion, but I can still get my answers here. I'm going to get rid of that. We also know that the two centers are 18 inches apart. So if this is 18, that is the hypotenuse of a right triangle. So if I take that right triangle out, the hypotenuse is 18, this leg is 9. So this is S, and this is 2S. So we have a 30, 60, 90 triangle. 30 will be here, 60 will be here, and this would be 9 root 3. If this is 9 root 3, the opposite side of the rectangle is 9 root 3, which also means the external tangent down here is 9 root 3. Both of those are part of the length of the belt. So that's this part of the belt and this part of the belt. When you add those two together, you get 18 root 3. That's a portion of the belt. Let's look. I think that it's harder to look at this side only because your angles, you have to realize that this was a 30, 60, 90 triangle, and we also have this right angle here. You have the same thing going on the other side. So right angles here, right angles here. If we were to draw a line, that's not super parallel, but it does the job. Right angle, right angle, right angle. So we now have another 90 degree right angle and another 30 degrees. So total for this side, it would be 90 plus 90 is 180. 180 plus the 60 is 240. So what that means is that this angle right here would be 120. Because I need to have 360 minus the 240, and that gives me 120 degrees. So that arc would be 120 out of the 360 times the circumference. And the circumference would be 12 pi because the radius is 6. So then from here, this can simplify to 1/3. We also have this simplifying to 1 there and 4 there. So the length of that arc is 4 pi. We're going to need that information to add to the other arc. So the arc on the other side, let's do green. We know that this is 60 degrees right here, and so this one's 60 degrees. So total, that's 120. Therefore, this arc is going to be 360 minus the 120, so it's 240. So to calculate the length of the arc, it would be 240 out of 360 times the circumference. And the circumference would be 30 pi because the radius was 15. So this simplifies to 2/3, and then 3 and 30 can simplify. 3 goes to 1, 30 goes to 10. So when I multiply across, I get 20 pi for the length of that arc. So now we need to add the two lengths of the arcs together, which would be 20 pi plus 40 pi to give me 24 pi. And this is the final answer for number 8.